6.4, in my thoughts, we're going our third direction in Chapter 6. We started talking about vectors. We spent a lesson talking about parametric equations. And now we're going to spend a little bit of time talking about polar coordinates. Okay, so you see the spiderweb looking thing down there, right? I don't know. Strikes me as a spiderweb. But the unit, it looks like the unit circle also. Well, that is also the polar coordinate grid. Okay, so when we graph on the regular square grid, right, those are rectangular coordinates. Well, we're going to look at the relationship between rectangular coordinates and polar coordinates. Okay, so rectangular coordinates are what you've grown up doing for years, and so what's the order of a rectangular coordinate? That's an x, y. Okay, well, polar coordinates don't use x and y because, as you can see, they are graphing on the unit circle type thing, and they use r, comma, theta. Okay, so we're going to use r, comma, theta, where theta, of course, is your angle, and r, I think it officially stands for radius. We're talking essentially how far out we measure there. Okay, so there are four relationships between rectangular and polar coordinates that we're going to use. So a lot of this lesson is how do we go back and forth between rectangular and polar coordinates? If we know this about rectangular, what do we know about polar, and vice versa. Okay? I think I'll write those down and then we'll talk about a picture here. So first of all, x is going to be equivalent to r cosine theta. So as in x from the rectangular coordinates is equivalent to r cosine theta in polar coordinates, which should make a little bit of sense because we've talked all along about in an ordered pair what comes first when we're on the unit circle, yes? In an ordered pair, it is cosine then sine. So there should be a logical connection that x is r cosine theta. You want to take a guess what this next piece is then? Y equals r times sine theta. Okay, so those are good ways to get back and forth if you are given your polar coordinates, so given r and theta, it's a good way to find your rectangular coordinates. Okay, we're also going to talk about the fact that tangent of theta is equivalent to y divided by x. Okay, tangent of theta, so tangent of the given angle is equivalent to y divided by x. And again, that should kind of make sense in a way because y divided by x would be sine divided by cosine. Tangent is sine divided by cosine. And then our other piece is that r squared equals x squared plus y squared, which should definitely sound familiar, right? Yes. All of these are, really connecting things that we already know. Okay. Okay. Let's see here. We're going to use.
That's like a straight line.
It is. Are you saying it's not very straight? No, I know, because as I was drawing, I was like, ooh.
I just didn't know if it had to have like a little curve.
No, here, let me, because I was thinking that, I was like, man, this doesn't look
Mine's not going to be straight either, but.
I managed to make it not straight with a ruler.
Okay, that is supposed to be a straight line connecting the origin to point P. Okay, that was not supposed to be the original curve, because as I drew that, I was like, yeah.
I wasn't trying to be like.
No, I know.
I just
No, it's a valid question. It is. Okay. It is. Okay, so, as we talk about this point, okay, when we talk, let's see, about this point, it can have two names for it, okay? And let me find, okay, it can have the name xy, which is what you're used to, yes? But when we talk about this in polar coordinates, this same point is the point r comma theta. Okay? So we can talk about it in both ways. Now, when we talk about, let's go with the XY first. When we talk about XY, the horizontal axis is our X, the vertical is our
Why?
Y. And so when we're trying to get to point P, we go what? We go over X, and then we go up Y. That's old news, right? This is just trying to, get some information. And then I referred to this earlier as the origin, yes? Okay, that is the origin. We also reference it as 0, 0, correct? Okay. Now, that all leads into our polar coordinate information. Okay. In the polar coordinate, it's no longer xy. It's no longer right x and up y. It's no longer x-axis and y-axis. It's no longer the origin or 0, 0. Okay. So the horizontal axis here to the right is what we call the polar axis. So basically, like when you think about your unit circle, your 0 degrees, that is your polar axis. Okay. The center is no longer called the origin. We call it the pole. And when you talk about the pole, it would be just denoted as the number 0 and not the ordered pair 0, 0. And let's see, what else? Theta. Where's theta? Theta is going to be the angle that talks about how far we are from the polar axis. And then, of course, r is the radius. Now, did I get all my labels and connections in? I think I did. There is a figure, and I don't have the correct page number here, but there is a figure in the book, if you ever want to look, that has a pretty decent drawing, if I recall. I'm going to try and grab, oh, maybe. Yeah, so on page 480 in your book, you have the same thing with all the similar information, okay? So, okay. Got it all down? Now, do you see where some of these connections are? Does x squared plus y squared equal r squared make sense? X squared plus y squared equals r squared, right? We've done that already this year. That's because, we're going back a lot to our unit circle and trig there. Tangent of theta. Tangent of theta is equal to y over x. Okay, so there's your SOHCAHTOA relationship. And then x being your r times cosine theta. And again, we could, if you look at cosine here, cosine of this angle is going to be x over r. But if you solve for x is going to be r cosine theta. If you look at this angle, sine of theta is going to be y over r. But if you solve for y, it's y equals r sine theta. So all of that makes sense. Ready to try graphing some of these? Sure, why not, right? Okay. Now, as we look on this unit circle, it's not labeled. I believe the one the one I usually copy and give to you guys is labeled. But I am going to encourage us to label a little bit first. And with that in mind, okay, now, when it says the dark line, I don't know if you can tell what the dark line is, but the dark line is this right here, yes? And what did I call that up above when we talked about polar coordinates? This is the polar axis, okay? And you'll notice it's only the right side, okay? So if you want, you could say it is the ray from 0. And then the center, I talked about this up above, the center is called the pole. Okay? Or in other words, the point there in the center. Okay. Yeah, I definitely think we're going to do some labeling here. So, what do we know about our polar axis? It has a measurement of 0, right? And you will notice, because we're talking about theta here, we are going to talk in radians. What are my 3 angles in the first quadrant?
30, 45, 60.
Okay, now put them in radians.
Pi over 3, pi over 4, pi over 6.
Yeah.
Other order.
Pi over
5 over
6.
6, 6, 5 over 4, 5 over 3.
Because smaller denominator is the, or excuse me, bigger denominator is the smaller angle. Right? Okay. What is, what you guys are going to tell me 90 degrees, what is that?
5
Pi
over
over
2.
2.
Pi over 2. Okay. Now, I'm going to skip for a moment. Well, I don't know. What is 180?
2 pi.
Pi.
Just pi.
1 pi, yes? Because this was 1/2 pi, this is pi. Now, in between, and this is one of those things where it's helpful to try and start to learn how to label this. Because calculus, you have to know these labels. Okay, that's something we have to work with. I know, we haven't really stressed that a lot, but it's just helpful, you know. So as I label these, keep in mind, okay, on the right here, this was up a sixth, up a fourth, up a third. Guess what over here? It's kind of equivalent. Can you see that? So this one up here is going to be something over 3. The middle one's going to be something over 4. And this one's going to be something over 6. Does that make sense? Okay, it's kind of reversing from the other side. And then think about it. When we get over here to pi, so if we think about the thirds, here's 0. Here's 1 pi over 3. This is going to be 3 pi over 3. What's that make this one? 2 pi over 3. If we think about fourths, this was 0, 1/4. What's this? 2/4. And so that makes this one 3/4, because down here we're going to be at 4/4, yes? What about this sixth?
5,
It's 5/6 because we're right before 6/6, yes? Okay. Now, this next quadrant is right after 1 pi, yes? And as we think about our denominators, the closest one to the x-axis is going to have a denominator of 6. So it's going to be 6, 4, 3. And technically, we could make these all the same denominator and talk 12ths, but... Okay, so now from pi, what is a sixth past pi? 7 pi over 6. What is a fourth past pi?
5,
5/4. And what is a third past pi?
4.
4 pi over 3. Okay.
Isn't that 2 pi? 2 something?
3 pi. 3 pi over 2.
So this is, we are in between 1 pi and where is 2 pi? 2 pi is going to be over here at 0 when we get back there. So this is 1.5 pi, aka 3 pi over 2. Sorry, I'm turning this into a labeling lesson, but I think it's helpful. It's not something we've really done. Okay, now, I think in this quadrant, what is right before 2 pi? Okay, now, did you get your denominators? Have you figured that out? The closest one to the x-axis is going to be sixths, fourths in the middle, and then the farthest one from the x-axis is your thirds. What is a sixth away from 2 pi?
11.
Because what is 2? 2 is going to be 12 pi over 6, right? So one before that is going to be 11 pi over 6. Do the same thing with fourths. 7 pi over 4 is going to be right before 8 pi over 4. And what about thirds?
5 pi.
5 pi over 3. Or really, we never skip thirds. If you just walk around, 1/3, 2/3, there's 3/3, 4/3, 5/3. I don't know. A little old labeling lesson there. The more you know, the better you are. Okay, guys. We're ready to do the bottom. Our job is to, I think I'm going to go back. There we go. Plot these points. Okay? Now, keep in mind, the order for polar coordinates is r comma theta. But you'll notice what it says. It says, first plot the theta, then the r. And so in an xy coordinate, a rectangular coordinate, we go x, then y, correct? Well, here we're going to go, yeah, kind of, theta, then r. Okay, so you're going backwards here. Now, I am going to call this first point A, because I need a way to label these so that we know what's what, and I don't have to label them, you know, with what their actual numbers. So 3 comma 2 pi over 3. So first of all, we find theta. Where is 2 pi over 3?
Here.
Okay, it's this line right here. What does an r of 3 mean?
3 rings.
That means you're going to count out 3 rings. Can you see where I put my point? That is point A. Or whatever you want to call it, but A is easiest for me.
Did
Okay?
you just go down and label all the rest of letters?
Yes. Yeah. I have this that we are going to be graphing A, B, C, D, and E. Because this way you can look back later and know what each point is. So. Okay, we ready to try B? Okay, making you think already on the second one. 4 comma negative 3 pi over 4. So, negative 3 pi over 4.
Would
No.
that be 4 pi over 3?
Well, first of all, we're talking negative 3 pi over 4, so we've got to find another fourths angle. You guys are throwing some crazy stuff out at me.
7
Oh.
over 7.
I'm sorry, I heard 6, I heard thirds. I'm like, no. The one thing I do know is it has to be a fourth. Okay? So what's a negative tell me to do? Instead of going up and around, we go down and around. So what's the equivalence of traveling 3 pi over 4 but going down instead of up?
5 pi over 4.
Exactly. This right here is equivalent to negative 3 pi over 4. So now we're going to go to that angle there. What's my r value? So we're counting out 4 rings. And that is my B. Okay, so a negative theta just means you go backwards around the unit circle. You go down instead of up. Okay, C, 1 comma pi over 4.
Pi over 4 right there.
Okay, pi over 4 in the first quadrant. 1 says 1 circle out, and in that very tiny spot, yes? That's going to be my C.
How do you do negative rings?
Okay, D. So, negative 2 comma 7 pi over 6. So first we go to 7 pi over 6. Where is 7 pi over 6? Right here, yes? Here's my 7 pi over 6. Now, we have an R of negative 2. So positive 2 rings would take me right here. What's negative 2 going to take me?
The other way?
The other way. And so we're actually going to end up in quadrant 1 on pi over 6. So this, let's see, what is this? This is point D. This goes back into, just like angles on the unit circle, these points have multiple different options. Okay, so this point D, if I was looking at this, whoops, I would just call this 2 comma pi over 6. But is that what we just graphed? No, we just graphed negative 2 comma 7 pi over 6. So in other words, these are equal names. You know, if you call this 2 comma pi over 6, that's another name for it. Now, I'm not saying you have to be able to list that name, but I'm just want you to realize that that's what it's equivalent to. So you go backwards through the pole when you have a negative R value. Are we good there? Okay. That takes us to E. Negative 1, negative pi over 3. So first of all, where is negative pi over 3? Instead of going up pi over 3, it's down pi over 3, and that puts us at 5 pi over 3, yes? And then what's negative 1? Instead of coming down on 5 pi over 3, we're going to go backwards to the pole, and we're going to be on 2 pi over 3. So if you want to, you can call this 1 comma 2 pi over 3. We could also call it negative 1 comma 5 pi over 3, right? Because we also did negative 1 from 5 pi over 3. So again, there are unlimited names for these points. You know, rectangular coordinates so much easier. You go this way, you go that way, that's your point, that's your name. Here you've got multiple options. Okay, questions on graphing those? Okay. I will give you a piece of graph paper. Or basically just, I think if I recall, I just give you one unit circle or one polar graph, and you can do like this and put them all in the same one. But I forgot to get that ready. So, the homework's not due tomorrow. So, yeah, how many of you even will actually start the homework?
It's not looking good.
I'm not
Very
gonna lie,
few of
I
you.
probably won't do it.
Usually very few to none. I don't know.
Probably none today.
I'm sorry to those of you that might actually have considered starting it. My apologies. It's very few to you.
Graph paper to start.
No, I didn't do it.